This is our homework 3 video. We are going to be drawing slope fields to understand what would be the shape of the solution to this differential equation. All we need to do is take our points and plug them into our derivative. It might be best when you do this to write down the points. You know, like 1, 0. When x is 1, y is 0. I'm going to have an undefined or vertical tangent. 1, 1. X is 1, y is 1. I'm going to have a slope of 1. We need to know that positive slopes of 1 look like that. Let's look at 1, 2. 1 over 2 will be a half, so we're going to look like this. Just aim down 1 over 2. I'm aiming at this guy. 1, negative 1. So that'd be 1 over negative 1, negative 1. Aim at 0, 0. 1, negative 2. Negative a half. Aim over here. Okay? And that's just one example. Some things we can do quickly is if we see that y is 0, we'll have a vertical tangent. When x is 0, it's 0 over 1, 0 over negative 1, horizontal tangent. And then usually, depends on the symmetry of things, we'll see opposites. So 1, 1, 1, negative 1, that's going to be a slope of negative 1. Negative 1 over negative 1, that's going to be a slope of positive 1. Negative 1, positive 2, so negative 1 over 2, negative a half. This will be positive a half. Negative 2, 1, that will be negative 2. So aim down here. Negative 2, negative 1 will be positive 2. And then these would be opposites. So positive 2, positive 1, slope of positive 2, aim down here. And then this would be a slope of negative 2. Let's do the next one. X plus y. Okay, cool. So 1, 0 is going to be 1. 2, 0 will be 2. 0, 0 will be 0. I didn't really include that, but go ahead and put that there. Negative 1, 0, negative 1, negative 2, 0, negative 2. 1, 1, 2. 1, 2, 3. So down 1, 2, 3 over 1. I'm aiming at this one down here. So steeper than this 2. They're both aiming at the same thing though. 1, negative 1, 0. Might as well put 2, negative 2, 0. Negative 1, 1 is going to be 0. One, 0 is 1. Negative 1, 0 is negative 1. 2, negative 1 is 1. Negative 1, 2 will be 1. 2, 1 will be 3. Aim at that guy. 1, negative 2 will be negative 1. This should be negative 1, 2. This is a little too steep for negative 1. I should be aiming at that guy. Negative 2, 1, negative 1 as well. Negative 1 is negative 2. Aim at that guy. Negative 1, negative 2 is negative 3. Aim at that guy as well. Negative 2, negative 1, negative 3 as well. Okay? Definitely funky looking. You know, what is the goal of these? The goal is to kind of be able to see potential solutions like this or this. Okay, and that will hopefully help us when we're solving these differential equations, make sure that our solution is what it's supposed to be. And we'll be doing that on some of the other homework problems. So, all right, x squared y. So let's talk about when y is 0. Everything's going to be 0. When y is 1, we'll have x squared. So 0, when x is 0, everything's going to be 0 as well. 1, 1. This would be 4. 1, 2, 3, 4, really steep. 1, negative 1. Let's stay up here. Negative 1, 1 will be positive 1. Negative 2, that'd be positive 4. So again, very steep. Talk about 1, 2. So when x is 1, y is 2, the slope is 2. When x is negative 1, slope of positive 1 times 2, that's slope of 2 as well. 1, negative 1, I'd have a slope of negative 1. 2, negative 1, I have a slope of negative 4. 1, negative 2, negative 2. Negative 1, slope is negative 1. Negative 1, negative 2, slope of negative 2, just like these. Negative 2, negative 1, that'd be a slope of negative 4. Okay? xy minus y. All right. Well, if x is 1, all these are going to be y minus y, which is 0. So 0, 0, 0. It might be easier if I factor out a y. It's like that. Maybe. So when x is 2, I'm just going to have 1 times y. So another 0. Whenever y is 0, this will be 0, so that's easy. So this will be a slope of 1. This will be a slope of negative 1. If x is 0, it's going to be the opposite. It's going to be negative 1 times the y. So this will be a slope of negative 1. This will be a slope of positive 1. If x is negative 1, then it's negative 2 times y. So this will be negative 2. This will be negative 4. This will be positive 2. This will be positive 4. And then if x is negative 2, that would be negative 3 times y. So this would be negative 3. And this will be positive 3. One half x plus y minus 1. I don't know why I did this to myself, but whatever. All right, for this situation, it's probably easiest just to write down some points. Start with when x is 1. Probably should start when x is 0. So I'd get 0 plus 1 minus 1, which is 0. So 0, 1 is 0. 0 plus negative 1 minus 1, negative 2. 1, 0 would be 1 half plus 0 minus 1. So that's going to be negative a half at 1, 0. So a half will be going that way. 1, 1 will be 1 half plus 1 minus 1. So that's 1 half as well. But it's positive a half. So aiming at this guy will be a slope of a half. 1, 2. I should try the 2's, but whatever. 1 half plus 2 minus 1. So that's 1 plus a half. It's just 3 halves. 1 and a half. Rise 3, run 2. So 1, 2, 3, 1, 2. Positive. I'm aiming at that guy. 1 negative 1, 1 half minus 1 minus 1. So it's minus 2 plus a half, which is negative 3 halves. Yep. So 1, 2, 3, rise 3, run 2, aim at that guy. 1 negative 2, 1 half plus negative 2 minus 1. So it's negative 3 plus a half will be negative 5 halves. So 1, 2, 3, 4, 5. Aim approximately over here. All right, let's try x is 2. That'll be easy because we'll have 1 half 2 plus 0 minus 1, which will always be 1. 1 minus 1 is 0, so 2, 0, 0. 2, 1. 1 half 2 plus 1 minus 1, which would be 1. 2, negative 1. 1 half 2 plus negative 1 minus 1. That'll be negative 1. Okay. Let's talk about the negative ones. Negative 1, 0. Negative 1, 1. Negative 1, 2. Negative 1, negative 1. Negative 1, negative 2. 1 half, negative 1, plus 0 minus 1. So that's going to be negative 3 halves as well. So down 3 over 2, aim over there. That's negative 1 half times negative 1 plus 1 minus 1 will be negative a half. One half negative 1 plus 2 minus 1 will be a half. Positive half. Positive half. I'm about there. Over 2, up 1 over 2. 1 half negative 1 plus negative 1 minus 1. Negative 2 minus a half. Negative 2 and a half. Negative 5 halves. So 1, 2, 3, 4, 5 over 2. About there. 1 half, negative 1 plus negative 2 minus 1, negative 3 and a half, negative 7 halves. So just pretend it's steeper. All right, a couple more to go. Negative 2, 0, negative 2, 1, negative 2, negative 1. 1 half, negative 2 plus 0 minus 1. So this is going to be negative 1 minus 1, which is negative 2. 1 half, negative 2 plus 1 minus 1. That'll be negative 1. 1 half, negative 2 plus negative 1 minus 1. Negative 3. 1, 2, 3. Oh, I messed up. This should go here. Negative 3. So 1, 2, 3 over 1, maybe up there. Aim for that. Okay. X squared, y squared shouldn't be as tough. I could probably do it without. Let's see, when y is 0, it'll just be x squared. So 1, 4. This will be 0. 1, 4. When x is 0, it'll just be minus the y squared. So this will be negative 1. This will be positive 1. 1, 1 will be 2. 2, 1 will be 4 minus 1, which is 3. 2 is probably too steep. 3 is probably not steep enough. Negative 1, 1, that's 1 minus 1 is 0. 1, negative 1 is going to be 0. 1, 2, 1 minus 4, negative 3. Negative 1, 2, that's going to be 1 minus 4, negative 3 as well. 2, negative 1, it's 4 minus 1, 3. 1, negative 2, it's going to be 1 minus 4, negative 3. Hope I'm doing this right. 0 minus 1. Yeah, I don't think I did this one right. 0 minus 1 should be negative 1. Negative 1, 0. That's going to be different. That'll be 1 minus 0. All right, that's good. Negative 2, 1 will be 4 minus 1. That's going to be positive 3. Positive 3. Negative 2, negative 1 will be 4 minus 1. That's positive 3 as well. Negative 1, that'll be 0. Why did I put 1, 1 as 0? I'm all over the place here. 1, 1's going to be 0 as well. 0, 1 is going to be negative 1. This and this should be the same. 1, negative 2 would be 1 minus 4, negative. 1 positive 2 would be 1 minus 4. That should be a negative. Okay. Negative 1, negative 2 would be 1 minus 4. It's negative 3. 1 positive 2 should be the same, right? 1 minus 4, negative 3. Maybe I got my positives and my negatives all screwed up. This is looking better. Shows you, like, even I have difficulty creating these. Like, positive slopes, negative slopes, they get messed up in my head. So you might have to double check your work. And then, to be honest, like, this is the way to go about things. It's going to take longer, but on your test, you're only going to have to create like one of these. On the AP test, you're only going to have to create like one of these. So if I'm wrong, I'm sorry. All right, given the slope field, draw a potential solution at the point given. Okay, well, we could see like, all right, if this is my slope field, and here's my point, I could draw something like this that would follow the slopes. You probably want to start at the point, to be honest. And you say, if I started at this point, it's like, let the slopes lead you from there. Something like that, right? Here, you know, it looks like this wants to go down if those are vertical lines, and then it comes up here. Excuse me. Okay, let's look at this guy. Hits it, comes back down, keeps going down. Okay, then I go the other way. Okay, hits that, it's gonna hit that. It's gonna come up, come over. Okay. All right, let's see. This one looks like I'm gonna go up like that, pop down like that. This one, it looks like we're just going to shoot straight up, something like that. This one's cool. So I'm going to be going up constantly, down constantly, and then I get to this point, go up like that. Match both the differential equation and the solution to its given slope field above. All right, cool. Well, like, we just sketched some solutions here. Like y equals absolute x. We could see this is the graph of y equals absolute x. So I say, all right, the solution getting very frustrated by this computer freezing all the time. What's going on? Okay, solution y equals absolute x. We could also see like absolute value of x over x. These values are either 1 or negative 1. You can see all these slopes are 1 or negative 1. Let's look at another one that's obvious. This guy. This really looks like y equals x squared, right? My differential equation must be like a cubic, right? If you think about the solution, its derivative is like 3x squared. Well, here's an x squared. No. Oh gosh, I just messed up there. If this is my solution, its derivative is 2x. If I plug in positives, it should be positive. X's and all consistent. If I plug in negatives, I better get negatives. Okay? This guy looks like either the square root function or a log function. I look and I see I don't have a square root function, but I do have a log function. It's probably log absolute x, which means the differential equation, the derivative of log x is 1 over x. You can see 1 over x. It must be the differential equation. We can tell that this solution is a trig function. So it looks like it's sine x. Yep, y equals sine x, because it starts at 0, 0. That means its differential equation must be cos x, the derivative of sine x. This solution must be an x cubed. I see they're looking for 1/3 x cubed. Well, the derivative of 1/3 x cubed is x squared. And here, this looks like an exponential function. So the solution is y equals e to the x, and its differential equation must be e to the x. Okay, so a bunch of different ways to do that. I want to get into this one, and you'll see questions like this on your test. If this is the slope field, which one of these is the differential equation? The way we tackle these is the following. We look at very specific slopes that are obvious. Here are obvious slopes. When x equals 0, dy dx better be undefined. Another set of slopes. Here are these zeros. It looks like when we have y equals negative x's, like at the point 1, negative 1, right here, the point 1, negative 1, 1. My slope better be 0. Understanding those very obvious slopes these are where you should start. I should start by plugging in 0 for x. Let's work with this one first. If I plug in 0 for x, am I always going to be 1 over 0? No, this one's out. If I plug in 0 for x, am I always going to have a 0 in the denominator? No, this one's out. Brings me to these two. If I plug in 0 for x, yes, could be. If I plug in 0 for x, yes, okay, that could be. Now I'm going to use the other 2 points. If I plug in negative 1, 1, I better get 0. So let's see. At negative 1, 1, I'll have negative 1 plus 1 over negative 1. That's 0. Okay, that's good. If I plug in negative 1, 1 here, I should get 0. Negative 1 squared plus 1 squared over negative 1, that's going to be negative 1. Negative 2, not 0. That's why that's out. That's why this is the answer. So utilize your obvious tangent slopes to create some points that you could check. Maybe I'll write that down and be a little bit more clear about this if you're just looking at the key. dy dx equals a number over 0 when x is 0, and dy dx equals 0 when y equals negative x. Like 1, negative 1, negative 1, 1. Plug in to check. All right, now that we've gone through and kind of been able to visually see differential equations using slope fields and potential solutions, let's actually solve some. So we got to remember we need to use a technique called separation of variables. I don't know how to spell separation. Is it with an A? Yeah, it's got to be with an A. Separation of variables. We need to algebraically get your y's with your dy and your x's with your dx. In this situation, I can multiply by y and multiply by dx. After getting your y's with your dy and your x's with your dx, you'll take the antiderivative of both sides with respect to the variable. 1 half y squared equals 1 half x squared. Now recall, we are used to saying an antiderivative has a plus c, and this antiderivative will have a plus c. But these could be two different c's. But what we'd end up doing is just subtracting one c from the other. They would end up canceling, which is why we only need one c on one side. We have to know that when we want to solve for y, when we manipulate things, I'm going to multiply everything by 2 just to solve for y. 2 multiplied by 1 half is positive x squared. 2 multiplied by c, you do not have to write 2c. 2 times c is just c. When you take the square root to solve, you got to understand you need a plus or minus x squared plus c. However, this is not a function. You are told you have only one point. F of 1 is only equal to 4. So even though the original implicit equation is probably some sort of hyperbola, so like x squared minus y squared function, which we can see, x squared minus y squared, or minus equals c, yeah, x squared minus y squared equals c. We're looking for only like half of that. So if I plug in 4, if I plug in 1, I better only get the positive from the square root. Because I need, if I plug in 1, I better only get positive 4. So this turns into 4 equals just root 1 plus c. I square both sides. I get 16 equals 1 plus c. c is equal to 15. So I don't put plus or minus, just the plus. Because I want y equals f of x. It's not fair because, like, last unit when we did implicit derivatives, I didn't start with functions, but going this other way around, we want functions. So the solution is x squared plus 15. Don't have to put this plus, obviously, but I'm just going to put it for emphasis. Let's try this one. Again, we need to separate our variables. I can multiply by y, move it onto that side, multiply by dx, move it to that side. I get y dy equals negative 2x dx. Take the antiderivative of both sides. I get 1/2 y squared equals negative x squared plus c. 1 plus c, multiply by 2, y squared equals negative 2x squared plus c. I don't have to multiply it by c there. Y will equal plus or minus root negative 2x squared plus c. See how the c is underneath the square root. That's very important. Okay, when I plug in 1, I better get a negative 2, which means I'm going to just need the negative half of my plus or minus. So I get negative 2 equals negative root negative 2 plus c. You take the opposite of both sides. Square both sides. 4 equals negative 2 plus c. c will equal 6. So my solution, sorry, is y equals the negative half of root negative 2x squared plus 6. All right, now I got another one. I got 2x times y squared. I'm going to go ahead and multiply by 1 over y squared. It'll move the y's over here to be the dy. I'm going to multiply by dx. Give me 1 over y squared dy equals 2x dx. I'm going to take the antiderivative of this. So on the left side, before I take the antiderivative, I understand that this should be written as y to the negative second to use the power rule. Gosh. It's y to the negative first times negative 1, the antiderivative. And this will be x squared plus c. So I got negative 1 over y equals x squared plus c. Now what's important is that to find c, you can find c at any point. I like to solve for y first and then find c. The way I'm going to solve for y is to take the opposite of everything. I don't have to put a minus c though. This is very important. Like, I'm going to show that step actually. So multiplying everything by negative 1. I'll have 1 over y equals negative x squared plus c still, because it's still like c times negative 1 is still c. Excuse me, sorry. All right, next thing I'm going to do, I like to flip both sides. Just take the reciprocal of both sides. Put y over 1, put 1 over all this stuff on the right side. You got the initial condition 1, 4, so 4 is equal to 1 over. So this is important. It's not negative 1 being squared. It's 1 being squared that's taking a negative sign to it. So make sure we are comfortable with that. Now, probably to solve for C, I would then flip both sides again. Maybe it would have been easier to find C first, who knows. And then I add 1. Adding 4/4 to 1/4, I get 5/4. So my solution is y equals 1 over negative x squared plus 5/4. All right. All right. Same kind of deal, but I'm going to multiply by y squared and multiply by dx. Giving me y squared dy equals 2x dx. Antiderivative of both sides. 1/3 y cubed equals x squared plus c. Multiply everything by 3. Y cubed equals 3x squared. Plus c. And cube root everything. Maybe you like to write it as the cube root. Maybe you like to write it as the 1/3 power. Don't really care. Here's your general solution. I have the point 1, -2. -2 equals. Yeah, notice with that cube root, I don't have a plus or minus because it's an odd power. I only need a plus or minus with an even power because even powered numbers are always positive. Don't have to worry about it here. You get 3 plus c here when I plug in 1. I'll cube both sides. I get -8 equals 3 plus c. Subtract 3, I'll get c is equal to -11. And then I have my solution. Y equals the cube root of 3x squared minus 11. All right, let's do a couple more. There's a similar situation to a previous one in that I need to multiply by 1 over y squared and multiply by dx 1 over y squared dy equals sine 2x dx. Take the antiderivative of both sides. We talked about how this is y to the -2nd. Its antiderivative is -1 over y. Okay, the antiderivative of sine 2x, we learned about this last class. It would be cosine 2x, but hold on, let's think about it. It's negative cosine, because the derivative of negative cosine is positive sine. And I need a 1/2. All needs to be taken into account. Now, we can take the opposite of both sides. We don't have to worry about the plus c. We can flip both sides. Making sure the c is flipped as well. F of 0 is 3. 3 equals 1 over 1/2 cosine 0 plus c. Cosine 0 is 1. I can flip both sides again. I get 1/3 equals 1/2 plus c. Subtract 1/2 from 1/3. So that's 2/6 minus 3/6, which is -1/6. So c is -1/6. Giving me my solution, y equals 1 over 1/2 cos 2x minus 1/6. Now, just like we've seen before, typically with the AP Calculus exam, they don't like to see fractions inside of fractions. I can remove that fraction by multiplying the top and bottom by 6, giving me 6 over 6 divided by 2 is 3 cos 2x. 6 times 1 6 is 1. I feel like I'm dying. No, this one should be fun. All right, so here I'm going to multiply both sides by 1 over 2y minus 3 cubed. Multiply both sides by dx. I can't really use this, so let's move this over. F of 0 is negative 2. Okay, so this is multiplying by 1 over 2y minus 3 cubed, and then multiplying by dx. That'll bring the y's with the dy, and the x's with the dx. Ready to take the antiderivative. Okay, we focused on this one last class. I would rewrite this as like the antiderivative of 2y minus 3 to the negative third. Take the antiderivative of the outside, leave the inside alone, then don't forget to multiply by the reciprocal of the coefficient of your variable. So watch what that'll look like. Antiderivative of the outside, inside left alone, but then I need another 1/2 for the reciprocal of the coefficient of your variable. Same on the right side, antiderivative of the outside, don't forget to multiply by the reciprocal of the coefficient of your variable. All right, so this is going to take a lot more space, so whatever. I got negative 1/4. I got 1 over 2y minus 3 squared equals 1/3 sine 3x plus c. I'm going to multiply everything by negative 4. One over 2y minus 3 squared equals negative 4/3 sine 3x plus c. What to do here? If you take the reciprocal of both sides, you don't have to use a negative power. So like, watch. I could write this literally as 2y minus 3 squared, but equals 1 over this entire right side. And this is fine. I'm not using a negative power because I am taking the reciprocal of both sides. I'm square rooting so that I get 2y minus 3 equals plus or minus root of 1 over negative 4/3 sine 3x plus c. I'm going to add 3. I'm going to divide by 2. Y will equal 3 plus or minus this root. Oh my gosh. I don't know why it's doing that. Oh. Divided by 2. All divided by 2. Not pretty, but this is correct. I have the point 0, negative 2. Let's bring this all the way up here to use that. So, negative 2 equals 3. Oh man, this is tricky. Could I get 2 solutions here? No. It's going to have to be the positive, the negative solution. 3 minus root 1 over 0 plus c divided by 2. Honestly, I might as well have put in the negative 2 for y here and not worried about the solving. So watch. plug in the negative 2, it's negative 4 minus 3, it's negative 7, equals, must be the negative root 1 over, plug in 0 to sign, that's 0, c. Take the opposite of both sides, square both sides, I get 49 equals 1 over c. C will equal 1/49, take the reciprocal of both sides. So, my solution is this with 1 over 49 plugged in. Messy? Yes. But really the key to this problem was our antiderivative step. Oh my gosh. Can I just get a straight line, please? I'm not feeling 100% as you could tell. Starting to get frustrated. And then this is just the negative half of things. Okay, similar deal here. Get the y over, leave the x's. 1 over y squared dy equals 1 over 3 minus x cubed dx. If I take the antiderivative of both sides, we have talked about how this is negative 1 over y. We can talk about how we'd write this as 3 minus x to the negative third. The antiderivative would be 3 minus x to the negative second times negative 1/2. But then I also need a negative from the reciprocal of the coefficient of x plus a c. So I get negative 1 over y equals positive 1 over 2 times 3 minus x squared plus c. Let's get rid of this negative, multiply everything by negative 1. Flip both sides. To do it properly, we should be putting the c in the denominator like this. Yeah, because you can't just leave it off to the side. It ends up not working out. So now that I have this, I'm certain there are ways to simplify this, but it's tough when I don't know what c is. I can multiply the top and the bottom of this by 2, 3 minus x squared, but then it would be next to the c, and we'd still have to incorporate it. So I'm really going to leave it like this, and I'll simplify later. I have the point 24, 1 over, negative 1 over 2 times, this is 3 minus x, so that's going to be just 1. Reciprocal of both sides, I have more space. 1/4 equals negative 1/2 plus c. Add a half. 2/4 plus 1/4 is 3/4. All right, now watch. So I'll have y equals 1 over negative 1 over 2, 3 minus x squared plus 3/4. Probably it would be best to give this a common denominator. So I'm going to multiply the top and bottom of this by 3 minus x squared. The top and bottom of this by 2. Watch while I do this. We get negative 2 over 4 times 3 minus x squared plus 3 times 3 minus x squared over 4 times 3 minus x squared. I can combine these two. 1 over negative 2 plus 3 minus x squared over 4 times 3 minus x squared. And then that is simply the bottom flipped as our final answer. Many of you are probably intimidated by simplification, but I'm showing you just in case, and know that this is an acceptable answer here. So you don't have to simplify it like what I did. Should have more of these, but I didn't. It's okay. What if we don't have x's? Okay. Leave the 3. Get rid of the y's. Right? Because the antiderivative would be negative 1 over y. The antiderivative of the right side, it's 3x plus c. Flip it, take the opposite. You got 0, negative 2. C is going to equal half. Take the opposite, flip it. Okay. So that's an easy one to finish with. You probably should multiply the top and bottom by 2. AP test does not like fractions and denominators. So what have we learned? Oh my goodness, we're not done. Okay, we'll keep going. Some of these are tricky, okay? Very tricky. But you have to be diligent, you have to understand the process, and you can't mess up on the antiderivatives. I'll show you, like, here's an actual AP question from an actual AP exam. There's a free response question. There's only 6 free response questions. It's worth 50% of your test. Typically 3 or 4 parts. Each total question is worth 9 points. Here's an example of a question. Slope field, sketch a solution that passes through the point 0, 2. Here's 0, 2, follow the slopes. 1, 0, follow the slopes. Okay, boom. There's like 1 point. You probably get 1 point for that. Part B. Let y equals f of x be the particular solution to the given differential equation with initial condition 1, 0. Okay, 1, 0. All right. Write an equation for the line tangent to the graph of y equals f of x and x equals 1. Use an equation to approximate f of 0.7. So this is like back in unit 4 stuff. You're given a derivative, dy dx. You're given a point, dy dx at 1, 0. So I plug in 1 and 0, and I get 4/3. I can use that point and that slope in my tangent equation. Y minus 0 equals 4/3 x minus 1. And I could use that to approximate f of 0.7. F of 0.7 will be approximately 4/3 0.7 minus 1. It's frustrating that they did that, but they do that often. They make you do some arithmetic. I'll say this is 4/3 times negative 3/10. It's 0.3, but whatever. It's negative 12/30, or that could be 2 over 5. So negative 6/15. Okay. Now, find the solution. So this is an exact differential equation. This would have been like worth 1 point. This is probably worth 2 points. This question, out of 9 points, there's probably a part D, but there might not be, is worth 5 or 6. And here's how the points are distributed. You will get 1 point if you are able to separate your variables correctly. To separate your variables, we would multiply by 1 over y minus 2 squared and dx. Oh my gosh. All right, so this is what I get. For 1 point, 1 over y minus 2 squared dy equals 1/3 x dx. That's worth plus 1. Typically, the antiderivative is worth 2 points. So each antiderivative, if you do it correctly, is worth 2 points. So this would be x squared times 1/2, so that's 1/6 x squared plus c. That's worth 1 point. Then I would understand that this would be y minus 2 to the negative first times negative 1. I do not need a reciprocal of the coefficient of y. That's worth 1 point. So plus 2 together. Then, if we are able to solve for y correctly and then find c correctly, that'll be our remaining points. So we already have like 3. I have 2 more points remaining. I'll take the opposite of both sides. I don't need it on the c. I'll then flip both sides. Let's just use the point now, 1, 0. Negative 2 equals 1 over negative 1/6 plus c. Flip both sides, negative 1/2 equals negative 1/6 plus c. Add a 6, so that's negative 3/6 plus a 6 is negative 2/6. Which is a third. Negative a third. And then our solution would be y equals, it would be y minus 2 equals 1 over negative 1/6 x squared minus a third. Y equals 1 over negative 1/6 x squared minus a third plus 2. Probably multiply the top and bottom of this by 6, but you don't have to. Okay? Finding c, solving for y, worth the remaining points. All right, this is from 2018. This is not that long ago. I'm going to double check because I feel like I did something wrong. I feel like I'm off right now. I'm coughing all over the place. I have the solutions to this that I did back in the day when the problem was done and given. No, I was right. Negative 1/6 x squared minus a third plus 2. All right, so there you go. And let's see, the actual problem from the actual exam, 2018, was worth, oh, this is just 3 parts. So literally, it was 1 point, probably 2 points, 6 points. It is easy to get a very high score on a question like that. All right, we got dy dx, also d squared y over dx squared. Okay, write an equation for a line tangent to f at x equals 1. Look at what they did there. They kind of said at x equals 1, they needed you to go back and say, oh, find f of 1 equals 2. Tricky. All right, so for part A, dy dx at 1, 2 is 1 times 2 cubed, which is 8. So I get y minus 2 equals 8 times x minus 1. All right, that's a review. B, use a tangent line equation of part A to approximate. So this is unit 4 again. F of 1.1 is going to be approximately 8 times 1.1 minus 1 plus 2, which is 0.8 plus 2, which is 2.8. Given that f of x is greater than 0 between 1 and 1, 1 and 1.1, is the approximation for f of 1.1 greater than or less than f of 1.1. So is this an over or under approximation? Well, they gave us the second derivative. Very nice of them to give us our second derivative. If f of x is greater than 0 when x is between 1 and 1.1, so y's are positive when x is right around 1, if I plug in positive y's and positive x's, my second derivative must be positive. When my second derivative is positive, my graph is concave up, and my approximation is under. So 2.8 is an under approximation because d squared y over dx squared is positive. That's all you'd have to write. C, find a particular solution. All right, so again, this is probably worth 1. This is probably worth 2, maybe 3. This is maybe 2. Maybe this is 2, but this is going to be like 5. So I would divide by y cubed. I got 1 over y cubed dy and multiply by dx. Antiderivative both sides. This is y to the negative third, so it'd be y to the negative second times negative a half. This would be 1/2 x squared plus a c. Multiply everything by negative 2. I'd have 1 over y squared equals negative x squared plus c. Flip both sides. Y squared would equal 1 over negative x squared plus c. Take the square root of x of both sides. I get y would equal plus or minus root 1 over negative x squared plus c. We're told f of 1 is equal to just 2. So when I plug in 1, I better get the positive 2. So I get 1 over, again, plug in 1, it's 1 squared, but it's negative 1. It's 1 squared first, then negative. Square both sides, I get 4 equals 1 over negative 1 plus c. Take the reciprocal of both sides, 1/4 equals negative 1 plus c. Add 1, 5/4 is c. My solution is y equals the positive root 1 over negative x squared plus 5/4. Probably multiply the top and bottom by 4, but really who cares? It's free response. As long as it's correct, it's good. This is from 2010. Let me look up these answers. I should have them somewhere. There it is. Oh, this will show the scoring guidelines, which is sweet. Part A was worth 2 points, finding f prime was 8, and then your equation of your tangent line, y minus 2 equals 8 times x minus 1. Part B, 2 points, your approximation. Understanding that your second derivative is positive, it's going to be an under approximation. 2 points. Part C, 5 points. Separating your variables worth 1 point. Your correct antiderivatives was worth 1 point. Including a plus c somewhere was worth 1 point. Using an initial condition worth 1 point. Solving, y is equal to 1. Y is equal to the positive root 1 over 5/4 minus x squared. What did I have? Minus x squared plus 5/4. They then multiply the top and bottom by 4. You do not have to multiply the top and bottom by 4. And then when you square root, you don't have to square root the top to get 2. Our answer is fine. So that's it, man. That was the homework. That was a doozy. It's a lot of work, these differential equations, but we have to practice them because They're easy questions on an AP test to get perfect scores on. So that's what we're going for. I will make sure I save this.